Hi, this is a quick tutorial for homework number 10 on impulse and momentum. And in these problems, for problem number 1, you're given the force in terms as a vector, in terms of i's and j's. And as a function of time. And you're asked to find the change in the particle's momentum between time t is equal to 2 seconds and 6 seconds. So remember, the change in the momentum is equal to the integral from t1 to t2 of f with respect to time. So for problem 1, we end up integrating the force with respect to time, and that gives us 32 Ti minus 19 over 2 T cubed, evaluated from the time 1 in the problem is 2 seconds to 6 seconds, and that comes up to a value of 128 newtons per second along the I direction. And minus 1320 newton seconds along the J direction. Alright, so for problem number 2, we're told that you have a baseball with a mass of 176 grams, which we convert to kilograms to be 0.176 kilograms. And it's initially moving along the X direction with a speed of 21 meters per second. And we're told that it strikes a fence at an angle of 45 degrees. And then it starts to move along the Y direction. So initially moving along the X, and then it switches to move 90 degrees up. And we're told that the speed remains unchanged, so it's still moving up with the speed of 21 meters per second. All right, so in this problem, we are asked to find the momentum, the change in the momentum given in vector notation. So its initial momentum along the X direction, so Vi or V1 is equal to 21, and I'll just keep writing meters per second, I plus 0J. And when it hits and it goes up in the opposite direction, its final, so V final V2 is equal to 0J plus 21I. Right. So the change in momentum, so delta P, is equal to M times V2 minus V1. So we have to write these vectors and these velocities as vectors and put them into this equation. So we end up with a mass which is 0.176 times V2 minus V1. So here we have 0J minus 21J. And so that will give us minus 21. I'm sorry. So that's I and that's J. So we have minus 21I. And on this side, we have a final 21J minus 0J. So we will have a positive 21J. So we have to multiply through by the mass of 0.176 kilograms. And so that gives us a change in the momentum of minus 3.7 I along the I direction and plus 3.7 along the J direction. All right, so for problem number 3, we told that we have an 11.5 times 10 to the third kilogram railroad car, which is traveling along a frictionless track and moves with a constant speed. All right, so initially we have our M being equal to 11,500 kilograms, and it's moving with the speed V1 of 12 meters per second. And then we told at some later time we drop a load onto it. So we have our railroad car plus some load. So it's initially moving in this direction, and we actually find what the new speed of this load plus the railroad car should be. All right, so we told that the load has a mass of 6,000, so M load, 6,350 kilograms. And the railroad car also has a mass, which hasn't changed, of 11,500 kilograms. All right, so initially the load has no speed, so its momentum will be 0. So we have to sum up the momentum before and after they join together. And so the initial momentum will be the mass of the railroad car times the initial velocity v1. And when you put a load on the car, they end up moving with the same speed. So on this side here, you have the mass of the railroad car plus the mass of the load multiplied by the final velocity. So the final velocity is equal to m times v1 divided by m plus the mass of the load, which comes up to be 7.73 meters per second. So you expect the car to move at a slower speed to conserve its momentum relative to its initial speed. So the final answer has to be less than the initial speed of the car alone. So for problem number 4, we told that you have a tackler, 100 kilograms tackler moving at a speed of 3.5 meters per second. And he told that he collides headlong with another football player who is moving at 5 meters per second. So since they collide headlong, they will have to be moving in opposite directions to collide headlong. So the other guy is moving with some speed of 5 meters per second. And he weighs 90 kilograms. And so after some time, they collide and they both move in the same direction. So let's draw them stuck to each other, moving in some direction, which we just say it's moving in this direction. And we'll figure out the sign at the end. But we actually find a mutual speed, and the mutual speed is the amplitude of whatever velocity they end up moving together with when they collide. So the momentum before, so will be the 100 kilograms times this initial speed, 3.5 meters per second, plus the momentum of the other player, who weighs 90 kilograms. But since he's moving in the minus x direction, we'll have to put the speed here to be negative. And so that should be equal to, when they collide, we'll have the sum of their masses, so 100 kilograms plus 90 kilograms times this final velocity. And so we have to solve for V2. And since we try and find the speed, that will be the amplitude of V2, which will come up to be 0.526 meters per second. All right, so for problem number 5, you have someone on the boat who's holding a package, initially at rest. So V1 of everyone here is 0. And we told that at some later point in time, the person throws up a package at some speed, 10 meters per second. And we told that the mass of the package is 5.5 kilograms. The mass of the person is 27 kilograms. And the mass of the boat is 40 kilograms. And so we have to find what speed the person and the boat are going to move once this package moves, is thrown out at a speed of 10 meters per second. So V2, and since the person is still in the boat, the person in the boat should have the same speed after the package is thrown out in the opposite direction. So let's assume so we have to find V2. So before the person throws out the package, the speed is 0, so the initial momentum has to be 0. And on the other side, we have to find the momentum of the package, which is the mass of the package, times its velocity, which is 10 meters per second. And that plus the momentum of the person and the boat, so the mass of the person plus mass of the boat multiplied by the final speed should be equal to 0. So here we put in the mass of the person and the mass of the boat, and we solve for V2, and we find out that V2 is minus 0.821 meters per second. So in the first part, we actually put in the magnitude. So the magnitude would be the positive value of this quantity. And the negative sign here means that the person in the boat will have to be moving in the opposite direction as the direction in which the package is thrown. So we can go back to our figure here and draw the arrow here, which tells us what direction V2 moves. All right, the next problem is number 6. So we have a baseball with a mass 0.145 kilograms, which is initially moving with the speed of 35 meters per second. And we're told that it hits a pitcher's bat and moves back in the opposite direction. So this is V1. So the final speed when it moves in the opposite direction is 50 meters per second. All right, and at some point in between that, the ball hits the baseball bat. All right, so we're asked to find in A the magnitude of the change in the ball's momentum. I'm sorry. We asked to calculate the force, assuming that the time where it hits the bat, so delta t, the time of contact, is equal to 5 times 10 to the minus 3 seconds. Okay. So remember the force, the average force divided by the time is equal to the change in the momentum. And so the average force should be equal to the change in time multiplied by the change in the momentum. So the change in the momentum is the final momentum, which will be m v2 minus mv1 and when we're finding the average force, we need to find the amplitude of the change in the momentum. So this quantity average force will always be positive. So the average force here, since we're finding the amplitude, will be the amplitude of this change in the particle in the baseball's momentum. All right, so here we have delta t, and we have m, the mass, which is 0.145 kilograms, so I just write it as m. And V2 is pointing in a negative direction since it's coming back in the minus x direction. So we have a minus 50 meters per second. So minus V1, and V1 here is positive. And delta T is 5 milliseconds, so we find out that the average force exerted by the baseball bat comes to be about 2,470 newtons. So the trick here, or what you have to pay attention to, is that these velocities are vectors, so you need to consider, just like we've done previously, what directions they are moving, which tells us what sign you have to have in calculating the change in the momentum. All right. We'll skip over to question number 8. So we told that you have a ball of mass 275 grams, which would be 0.275 kilograms. And it hits the ground with some speed. So at this point here where it hits the ground, it's moving downwards with a speed of 3.16 meters per second. And then it rebounds, so it goes up with a speed of 1.55 meters per second. And the time of contact, so delta T in this case is equal to 2.6 milliseconds. So in part A, we asked to find the magnitude of the change in the ball's momentum. So in part A, we have to find the magnitude of delta P, which would be equal to m times V2 minus m times V1. And so if we assume the positive y is up, this would be our V1, which would be negative, and that here would be our V2, which is positive. So our change, the magnitude of the change of the momentum will be equal to the mass, so we can factor out the mass, V2 minus V1. And the mass is 0.275 kilograms. V2 is positive, so that's 1.55 meters per second, minus V1, which is negative. So even though we have a negative sign here, we also will have a negative sign here for the 3.16 meters per second, which gives us a positive value in the end here. So we have here 0.275 kilograms times 1.55 meters per second plus 3.16 meters per second. And we'll have to take the amplitude of this, which is already positive, and that comes up to be 1.3 kilograms meters per second. In part B of this problem, we have to find the change in the magnitude of the ball's momentum. So for part B, we have to find the change in the magnitude of the momentum. So part B, we have to find mv2 minus mv1, which is very different from finding the amplitude or the magnitude of the change in the momentum. So in this particular part, everything here is positive. So we have the mass times the speed, and V2 is positive. And we have to take the amplitude of that. minus the final, so the mass is still 0.275. And V1 is negative, but since we will be taking the amplitude, we can write it as the positive quantity. So this difference here comes up to be negative 0.443 meters per second. All right, and part B, we actually find the average force exerted on the ball due to the change in its momentum. So again, the average force, F average, in this case is a change in the momentum, the magnitude of the change in the momentum divided by the change in time. And so we put in this 1.3 kilograms divided by the change in time, and that gives us an average force of 498 joules, 498 newtons acting in the positive y direction.